Now we're going to learn how to find area of regular polygons, specifically triangles, quadrilaterals, and hexagons. So first we'll look at some new terms. So the whole thing right here is obviously called a side. But other than that, we have some new terms. This line going from the vertex to the middle is called the radius. So believe it or not, we have a radius of other shapes besides circles. It's going to the center. And then this dotted line, which goes from the center to a side, is called the apothem. A-P-O-T-H-E-M. And this is going to be the same no matter which of the shapes I look at. So for a regular quadrilateral, by the way, another name for that is square. Okay, we have our radius, our center, and apothem. That other thing you already know is a side. Same thing goes for a hexagon. We have a center, radius, apothem, and side. The other thing that we're going to add on this page is that they actually are making special right triangles. So in my equilateral or my regular triangle, it makes a 30, 60, 90 triangle. You can remember that because equilateral meant that this whole angle right there is a 60-degree angle, so half of that is 30. Then we've talked about with a square, when I have that diagonal and this is still a piece of the diagonal, then it's going to make a 45, 45, 90 triangle. And then for a hexagon, it makes a 60, 30, 90. So this bottom angle is 60, and then the top one is 30. So we're still going to be using special right triangles. All right, so on the front of your foldable, it says that the area of a regular polygon is 1/2 P, that stands for perimeter, times little a, which stands for your apothem. So basically where this capital A is, it's 1/2 perimeter times apothem. So a lot of times what we're going to be doing is using special right triangles. So what I'm going to label first is my 30, 60, 90. So I have 30 degrees and 60. So I'm going to make my little table. If you can do your beautiful special right triangles without this, more power to you. So opposite of my 90 degrees is 4. So that means x is 2. And then my 60-degree angle is going to be 2 root 3. So the bottom of my right triangle is 2 root 3. And that dotted line is going to be 2. So that's my apothem, is 2. And then I need my perimeter. So since these are regular, that means this is taking up half of that bottom. So then this part is also 2 root 3, which means that whole side is 4 root 3. And that happens 3 times. So my perimeter is going to be 3 for the 3 sides times 4 root 3 for each side. So 12 square root 3. So to find my area, I'm just going to use those two things I found. Area equals 1/2 P, which is 12 root 3, times apothem, which is 2. And when I multiply all of that stuff, I get 12 square root 3. In this problem, because of those numbers, my 1/2 and my 2 basically cancel each other out. So let's look at this other triangle problem. Find the area of a regular triangle, aka equilateral triangle, with a perimeter of 96 square root 3 units. All right. So this one gave me the perimeter, so I can go ahead and write that where perimeter is, 96 square root 3. I'm going to draw my wonderful picture. I need my center, I need my apothem, and my radius, and that this is going to be 30 degrees. See if my stylus will write that tiny. Not really. That's okay. So perimeter, I have a triangle, so I can take my perimeter and divide it by 3 to get what each side is, which is going to be 32 square root 3. So a whole side is 32 root 3, which means that the part that is in my triangle, my little triangle, is going to be half of that, which would be 16 square root 3. And now what do I have? I have a part of a 30, 60, 90 triangle. X root 3, 2x, and it gave me the opposite 60-degree angle is 16 root 3. So that means x is 16, aka my apothem is 16. And then opposite my 90 degrees is 32, but that doesn't really matter in my life. So we just found my 16 is my apothem. So can I now find my area? Absolutely. Area equals 1/2 perimeter, which is 96 square root 3, times my apothem, which is 16. And when I multiply all of these things, I get a really big number. I get 768 square root of 3 for my area. Now let's look at a regular quadrilateral, aka a square. So some of you might come up with something a little faster for this. Totally fine. But we're just learning kind of a basic thing with regular polygons and applying it to what we know for now. And then we'll add in some things later. So what you need to know here, it gives you your apothem is 10. And it's making a 45, 45, 90 triangle. So that means if that apothem is 10, that this piece of your side is 10, which means the other half is 10. So my whole thing is 20. Is that enough to go ahead and find the area of a square? Absolutely. 20 times 20 is going to give 100. JK. 400. Sorry. Friday night mood, y'all. So if you already know that, then that is fine, but I'm going to show how the formula also works. So if one side is 20, that means my perimeter is going to be 20 times 4, which is 80. And the formula for a regular polygon is area is 1/2 perimeter, which is 80, times your apothem, which was 10. And sure enough, you get that your area is 400. So for squares, sure, we can just find the outside and then use our normal formula. But just want to show that this is another way that is consistent no matter what shape I have. Find the area of a regular quadrilateral with a perimeter of 16. So I'm going to draw my regular quadrilateral, aka a square, as a perimeter of 16, which means my sides are going to be 4. So if my whole side is 4, then the half for my triangle is going to be 2. And it makes a 45, 45, 90. So that means my apothem is 2. My perimeter is 16. And area equals 1/2 perimeter, which is 16, times apothem, which is 2. So area equals 16, which we could have also gotten, yes, by doing 4 times 4 is 16. Right now we only have the pieces of the puzzle to do these 3 shapes. We're going to learn more to be able to do any sort of regular polygon, so that's why we're building up from something we already know. All right, last one is talking about hexagons. So for hexagons, what you need to remember is that you have a 60 is your base right there, and 30 degrees. Okay, so it's kind of flip-flop from your triangle. All right, so we know that a side is 24. So I could find my perimeter real quick. It's a hexagon, which means it has 6 sides, so 24 times 6 is going to give me 144. And now I need to find my apothem. It's a special right triangle, x root 3, 2x. So if the whole side is 24, that means the little side in my right triangle is 12. So that's opposite my 30-degree angle, and I need what's opposite my 60-degree angle, which is 12 root 3. If I needed the hypotenuse, it would be 24, but nobody cares about it right now. Sorry. All right, so my apothem is 12 square root 3. So area equals 1/2 perimeter, which was 144, times apothem, which is 12 root 3. And when I multiply all that stuff, we get what? Another really big number, 864 square root 3. Just type 0.5 times 144 times 12 and put a square root of 3 at the end for good measure. And the last question, find the area of the regular hexagon with a perimeter of 24 units. So they gave me perimeter. We have 6 sides, so each side is going to be 4 units. Oh yeah, y'all are about to see the most beautiful drawing ever. Okay, I'm going to try really hard to draw this hexagon. that is not a regular hexagon, but we're going to go with it. You know, I tried. That's what's important, y'all. Trying. Okay, so each side is going to be 4 units, which means the little part of my triangle is 2. And remember, it's a 30, 60, 90. So we have x root 3, 2x. And this is the one opposite the 30-degree angle, so 2. So opposite 60 is 2 root 3. And my hypotenuse is, yes, I'm a math teacher, and I can, in fact, multiply 2 times 2, which would be 4. I don't need my hypotenuse, though. So now that I have that, we are going to plug everything in. So my apothem is opposite the 60-degree angle, so my apothem is 2 square root 3. My perimeter they gave me originally is 24. Area equals 1/2 perimeter of 24 times apothem of 2 root 3, which is going to give me 24 square root 3.